Hi everyone. In section 1.1 we're going to talk about the basics. So we're going to start out with a relation. A relation is not always a function. A relation maps the relationship between an input and an output. So it can be a relationship between time and distance, or any independent variable and dependent variable. A function is only a function if there's one output for every input. So I like to give the example of a vending machine. For every button that you push, there's just one item that is going to come out. There's one item for every button that you could push. So the vertical line test will test to see if a relation is a function, because it'll test if there's just one output for every input. So I'll give you an example. So let's say that we have a polynomial here. Let me draw a vertical line. We can move it, and anywhere on that relation, it's just going to pass once. So this one would be a function, because everywhere that vertical line goes, it would just go through once. But if we had something like a circle, draw a vertical line. Anywhere I put that vertical line, it's going to cross more than once. Except for at the very end, it's just, if it doesn't pass the vertical line test, just in one spot, then it's not a function. You can see right there, for this one x value, which is the input, there are two outputs, that one and the one up there. So output, output, and there's the one input. So if there are two outputs for one input, then we say this is not a function. This one is a function over here. The domain lists all of the inputs, and the range lists all of the outputs. So you can list it in different notation. It might be in set notation or interval notation. So for example, this is a function and it's some sort of polynomial, but the domain, since it's got arrows on either side, the domain will be all real numbers. So you could list it as all real numbers like that. The bolded R means all real numbers, or you could list it in interval notation with the parentheses saying it goes from negative infinity to positive infinity, or you could list it as an inequality. X is between negative infinity and positive infinity. So lots of different ways to write the domain, and then the range on that one would also be all real numbers. For an application problem, remember I said that it relates to variables, so this function is going to give the height after t seconds, so that means the height depends upon time, and so that would mean that the time is the independent variable, so time would be the domain, time in seconds, and then the range would be the height. So we talked about how a relation is only a function if there's one output for every input. A function is one-to-one if it's the other way around. Only one input for every output. So we can use the horizontal line test to test that. So I'll give you an example. If we used the circle again, and then we had a horizontal line, and we move that anywhere, it hits multiple outputs. So this y value, whatever this y value is, hits two inputs. So this, let's see, right about there and right about there. So we've got just two inputs for that one output of that y value. So this does not pass the horizontal line test, so this one is not one-to-one. Something like a line would be 1-to-1 because we have one input for every output. So we can do the horizontal line test there also. So this one is 1-to-1. So we can have some relations that are functions, but they're not 1-to-1. We can have relations that are 1-to-1, but not functions. So we're going to look at these, and I'm actually going to pull up Desmos. You can graph all of these in Desmos, exactly the way that they're listed. So give me a moment, and I'll pull up Desmos. Alright, so there's the first one. It's a line. So I just typed it into the first row there. And you can see that it does pass the vertical line test. If you drew a vertical line anywhere, it would just cross once. So it's a function. And if you did the horizontal line test, it also passes the horizontal line test. So it is a function and it is 1-to-1. And if we look at the next one, this is an ellipse. And kind of like the circle that I drew, it doesn't pass the vertical line test and it doesn't pass the horizontal line test either because it would cross more than once vertically and horizontally. So this one's not a function, nor is it 1-to-1. For the next one, I've got that one typed here. This is a parabola. So it does pass the vertical line test, but it does not pass the horizontal line test. So it is a function, but it is not 1-to-1. And then the last one, this one does not pass the vertical line test, but it does pass the horizontal line test. So it is not a function, but it is 1-to-1. Okay, we can use the vertical line test on both of these. If we draw our vertical line and move it, it just hits that 1 point, 1 point, 1 point, 1 point, all the way through. So it does pass the vertical line test, so it is a function. This one would not pass the horizontal line test though. We could do the same thing here. Taking this, it doesn't pass the vertical line test here or here or here. So this one is not a function. Because you can see for the input 2, we've got two outputs, -1 and 1. For the input 3, you've got two outputs, 2 and -2, and so on. In this table, for the one input of 8, so there's one input of 8, we have two outputs. And so that's not a function. But for this one we have one input, one output, so this one is a function. And we can look in the table for the function value at 2. There it is. So the function f of 2 is 35. So that's what that stands for, f of 2 being 35. Through 2 is the input, and 35 is the output. Alright, when we're evaluating, there's a couple ways you can do it. You can plug in, so I'm going to show that way first. So I'm just going to plug in -2 in there. So 3 times -2 plus 1, that gives me -5. You can also evaluate using Desmos. So I'm going to show you. You can type in f of x. So I'm going to go show you, if you're doing it on your like a phone or iPad or tablet or something, you can bring up in this keyboard and just type in f of x, or you can just type it on your keyboard if you have one of those, equals, and then I'm going to put the function, which was 3x plus 1, so 3x plus 1. So now that you have the function, you can tell Desmos to evaluate it. So I'm going to go back and do f of -2. Yep, -2. And you can see it gives me -5. And then you can evaluate wherever else. So you can do f of 1. And you can see that's 4. And that's the same thing that you would get if you were to actually plug it in and evaluate. If you're plugging in variables, we're plugging in -a here, so that would be 3 times -a plus 1, which you can then just write as -3a plus 1. With the negative out front, we're going to make the entire thing negative, so, and then plug in a, so that's negative, and then 3a plus 1, which we can write as -3a minus 1. For g, you can also do that in Desmos. So I'm going to show you typing in a fraction. It's pretty easy. So I'm going to call this one f of x also. I don't think it matters. I'm going to go ahead and type the divide, which is the little, it's a slash, just to make the fraction first, so I can type multiple things on top. So I've got 4x minus 5 on top, and then 9x plus 2 on the bottom. And then you can do f of -2. And WebAssign will probably want an exact answer when it has you give evaluations of certain things. So there's a little fraction button right beside, so you can click on that and it'll show you what that is as a fraction. You also get that when you evaluate, so 13 out of 16 is what you would get if you were to plug it in. So 4 times -2 minus 5 over 9 times -2 plus 2. F of a plus h, I'm going to plug in a plus h where x is, so that's a plus h plus 1, and then just to simplify, so 3a plus 3h plus 1. For this one, you can evaluate in Desmos if you'd like to. You can put in both f of x and g of x and then evaluate, or you can do it by hand. Really, either way is fine. So I'm going to plug in 7/3 into f of x, and then I'm going to plug in -2, which I've already done up there, so I'm just going to go ahead and say that this is 13 over 16, because that's what I evaluated right there. So either way, so this 3 times 7/3 is 7, 7 plus 1 is 8, and we're doing 8 minus 13 over 16, and that ends up being 115 over 16. Again, in Desmos, it's really nice, some of the features that Desmos has. I'm going to go ahead and make this G. I should have it a little bit ago also, but go ahead and put in f of x again. I'm not really sure why I deleted it. Alright, so now I've got f of x and g of x, and now I can say f of 7/3, whoops, minus g of -2. Turn that into a fraction, and that's what I got by doing it by hand. So Desmos is pretty cool. Alright, this is what's called the difference quotient. Which might not mean anything to you right now, but when you get into calculus, it's a really big deal. It's a really fundamental concept. It's actually where derivatives come from. So we're kind of practicing now for when you're going to need to use it later. So we're going to take x plus h and plug it in for x. And so that's going to be 3 minus x plus h squared, and then minus the entire function, which is 3 minus x squared. And then all of that over h. So it can be helpful to do this part off to the side because that's not x squared plus h squared. Please don't do that. So this is x plus h times x plus h, which is x squared plus 2hx plus h squared. So I'm going to put that in. And then I'm going to go ahead and distribute that negative. And then we're going to have some things cancel. So what cancels is these x squareds and this 3 and this 3. So I'm really just left with negative 2hx minus h squared over h. And these h's cancel. So I'm left with 2x minus h. And we have a bit of a restriction there because we've got h on the bottom, so h can't be 0. So that part, I think, is already listed in your web assignment, so you don't really have to worry about the restrictions because they kind of give that to you. This is the main idea here. And so later on when you start, when you're in your calculus course later on, that's a really important concept for where the derivatives come from. So it's important to be able to do that. But every time you'll have the main parts cancel, so that those 3's canceled and the x squareds cancel. For the next one, when you're evaluating, you can use Desmos if you want to, or you can do it by hand. So this one, negative 3 squared plus 2 times negative 3. That's 9 minus 6, which is 3.